Hey everyone, welcome to another episode of BioLogic Science News. Recently, I posted an episode about the chemical BPA and how it can alter sex differentiation in fetal rat brains, even when the exposure is at levels far below the EPA recommended safe level. Today, I want to talk about another study with BPA, published in the journal M Systems, and instead of rats, the study looked at the effects of BPA exposure in rabbits. The researchers in the study came from numerous universities, including Colorado State University, the University of Colorado, Cornell, Penn State, and the University of California, with support from the Department of Agriculture's National Institute of Food and Agriculture. In my last episode on BPA, I talked about exposure to rat fetuses, which gestate for a little more than 3 weeks. This study used rabbits, which have a slightly longer gestation period that's closer to a month. The pregnant mother rabbits were exposed to 200 micrograms of BPA per kilogram of body weight every day from 15 days into gestation until 7 days after giving birth. And the exposure to the pregnant mother affected the developing fetus, who became exposed to BPA from the mother's blood, through the placenta, and after birth through the mother's milk. When the offspring were 6 weeks old, their intestinal tissues were analyzed. The researchers' findings were worrisome, because they found that even though the infant rabbits didn't come into direct contact with BPA themselves, they were exposed when their mothers came into contact with it. This data suggests that BPA might potentially be transmittable from mother to gestating or breastfeeding infant in humans. The researchers also noted that the infant rabbits had several deleterious medical conditions, including chronic inflammation in their intestines and their liver, and low diversity in their gut microbiome. One of the researchers on the project is Jairam Vanamala, an associate professor of food sciences at Penn State, who said, quote, "What we are seeing is that both intestine and liver tissues are damaged, and we see that the gut diversity is low. The anti-inflammatory metabolites are low." Somehow, the BPA is affecting the bacteria that live in the infant rabbit's intestines, and killing off many of the gut microbe species that would normally be there in an otherwise healthy infant rabbit. This reduction in the biodiversity of the gut microbiome suppresses the rabbit's capacity to digest food and absorb nutrients. When the bacteria are removed or killed off, they can't produce metabolite compounds that aid digestion, and food simply goes through the digestive tract undigested. When gut bacteria are suppressed like this, it leads to a condition called leaky gut, where undigested food, fecal matter, and waste is absorbed through the intestines into the bloodstream. The gut simply lacks the necessary metabolites to safely break all these things down and digest them, because the BPA took out all of the healthy gut bacteria that ordinarily do that. The implications of this study are dire. BPA is present in all manner of consumer plastics, from Tupperware to water bottles to the epoxy lining on the inside of food cans. You ever have canned soup, vegetables, or canned pears, or anything that comes out of a can? The lining of that can that protects the food from the metal, that lining actually has BPA in it, and that BPA gets into your food, and you eat the food, it gets into your body. It's pretty much like a direct contamination vector. Recent studies have shown that the average US citizen is exposed to 8 times the EPA safe exposure limit every day, and that 90% of US citizens have BPA in their bodies right now. The presence of BPA in consumer goods has been shadowed by a rising trend in diseases involving gut inflammation, like colon cancer, Crohn's disease, and type 2 diabetes. The relationship between BPA exposure to humans and the rise in these types of diseases is a subject of intense research, because if a causal relationship or a strong correlation can be found, it would be a powerful motivator for legal change, for greater regulation of BPA, and other potential endocrine disruptors that are being used in consumer plastics.